Hi everyone, this is Mr. Adel Salah. Okay, welcome on board. This semester, inshallah, we'll discuss about math topics for semester 2. Okay, about logarithms, which is natural logarithms, and exponent function e power x. I'll explain basically the major points which will connect you with our academy, inshallah. The major points which is related to the nature of the function, the domain, range, intersects, how you can understand the functions, and how you can deal, okay, with all the challenges, okay, problems related to these two functions. Okay, so let's start. Let's discuss now. Check this. E power x and ln x. E power x, okay, graph. You can see that it's an exponent function features that it starts, okay, from negative infinity going to the positive infinity, but with this shape. It's increasing the growing shape of what e power x. And the ln power x, as you can see, it goes down until it reaches the infinity, but it never touch what? The, okay, asymptote. We call it what? The asymptote. What is the asymptote exactly, mister? The asymptote is any line, okay, which the curve trying to approach it, but it never touch it. Okay, so there is like types of asymptote. We call it vertical asymptote and horizontal asymptote. So the vertical asymptote, as you can see in the ln x, the natural logarithm, okay, so the curve is trying to touch the y-axis, but it never touch the y-axis. That's what we call this, the equation of the horizontal asymptote. Okay, as you can see here, check. So, okay, sorry. So the equation of the vertical asymptote, which is equal x equal 0. Okay, so the equation of the vertical asymptote is x equals 0, as the equation of any vertical line starts always with what? 0. And since the exponent function here, it never touched the x-axis, so we call the x-axis in this case my what? Horizontal asymptote. So this is a vertical asymptote, and this is what? Horizontal asymptote. So let's call it what? y equals 0. Okay, so this is a vertical asymptote, which is x is equal to 0, and this is a horizontal asymptote, which is y equal to 0. Okay, what are the major things that I need to understand in these two graphs? The first thing, okay, the asymptote we talked about. The second thing, the intercept. What is it? The intercept. Okay, which means that this graph, it touched the y-axis at which point? 0, 1. I need to prove that. How, mister? Check. So the first thing here, when I say I'm touching the y-axis, the exponent function, it touched the y-axis, means there is a y-intercept. When I say there is a y-intercept, means that x is equal to 0. Starting, how to get the y-intercept? F of x is equal e power x. In this case, I need to get the y-intercept, which means that x is equal to how much? 0. So in this case, y is equal to e power 0, and that is equal to how much? 1. So my intercept is 0 and 1, as you can see. Okay, this is one of the things that I need to put in my mind. The second thing is about the ln. What is the major point also? Is the x-intercept. When I say there's an x-intercept, I need to be careful. That means that I need to get y0 to solve the equation, which is the f of x is equal ln x, and now it's the term for f of x to be 0 here. So y is equal ln x, which means ln x is equal, or sometimes you call it ln x, okay? It's like it's different way of saying the function. Ln x is equal to 0, and that's happened where exactly? So check this, okay? If I say ln x is equal to 0, when that happens, it's a basic rule in logarithms, when x is equal to 1. So it's a rule. When what's inside the ln is equal to 1, that's always going to be 0. So ln 1 is equal to 0, so then already it's what? 1 comma 0. This is my x-intercept. Okay, so I get here the y-intercept, and I get here what? The x-intercept. Okay, and we talked about the horizontal asymptote, and we talked about also the vertical asymptote for the natural logarithms. What else? What shall I do now also? Okay, two things also need to put in mind: the domain and range of the functions. Let's go for the exponent function. Exponent function itself, if I want to talk about domain, it means what are the inputs that I can plug in inside x in the function e power x. Actually, everything. I don't mind. It's everything. Which means that Mr. Domain is x, so x belongs to all real number. That's my domain. It means that I can put any number beside the x. That's my domain. What about the range? Check this with me. The range, I can see that I will never touch the x-axis, so I will not jump to the negative part. So all the function is above what? 0. So in this case, y, okay, or the range, range, so it's y, so y is what? Greater than 0. That means that I will never touch the 0, and all the values of the image or the output that I'm getting from the function is above the x-axis, and that's what I call it my range. Okay, so the domain x belongs to all real number, and the range y belongs to what? Sorry, y greater than 0. What about the natural logarithms here? Okay, you can see that I will never touch the y-axis here. So in this case, my domain, so x, okay, so x is greater than 0. Why Mr. is greater than 0? Because as you can see here, all the values of x are positive, and I will never touch what? The 0, the x is equal to 0, the vertical line, which is the asymptote. So all the values of x are accepted to be there with me, which means the only solution which is accepted inside the natural logarithms, ln x inside it, I need to put what? Above zeros. You can try the calculator, put ln 0, it's not accepted. Put any numbers before 1, it's not accepted, it's going to be negative. So my starting point is above 0 always. My starting point is above 0. You can plug any value above 0. But remember always, once you just enter 1, we will come to the x-intercept, and after that it will go above. Okay, that's my domain. And what about the range? As you can see here, okay, just say domain x, so x greater than 0, and the range in this case, is what? Y belongs to what? All real number. As you can see, y belongs to all real number. So in this case, okay, I just mentioned 4 major things. First of all, the domain, the range, and the asymptote, and the intercept, whether it's an exponent or the natural logarithms. Okay, just small thing to discuss about the transformations. I'll just give you a hands out, okay, about transformations. Stay with me. Okay, one question here. If I have the function f of x is equal e power x, what is the change on the intercept, the domain, range, and the asymptote if I do one of the transformation here? Just a hands out, fast one, which is e power x minus 1. This is shift right by 1 unit. This is what? A horizontal compression by a factor of half. This is a translation 1 unit up. This is a horizontal stretch by a factor of 2. This is a reflection across x-axis, and this is a reflection across y-axis. I'll choose one only, okay, just to give you like a hand out, okay, on how the domain, range, intercept, and the asymptote will change, okay, based on the transformations, whether it's translation, vertical stretch compression, or reflection across x-axis or y-axis. Watch this with me. So in this case, such in case I want to do like shift 1 unit up. Shift 1 unit up, which means that starting from 0, the first jump is going to be here. Check this. The first jump, instead of like the horizontal asymptote, it was y equals 0. The new one is y equal 1. That's the first change because I chose what? To shift it 1 unit up. Okay, what's next? So the graph is going to be this way. Okay, which means that my new intercept point is 0 and what? 0 and 2. Okay, that's the second change. The third change here is what? Okay, now the intercept, the asymptote changed because you shifted it up by how many units? 1 unit. What about domain? Okay, still, I'm asking you the same question. Is anything going to affect the values that I'm going to insert it inside x? Of course not. I can insert whatever I want. So the domain is still the domain x, so x belongs to all real number, in this case the exponent function. But what about the range? Check this with me. Before we said that it was y greater than or equal 0. But the new one now is what? Y greater than or equal what? 1, because the asymptote changed. So the new function, the new curve will never touch what? The new horizontal asymptote. So in this case I can say that the range y, so y greater than what? 1. Okay, this was like a quick hands out, okay, on exponential logarithms. See you inshallah next week with a new video.